Our faces are more than just features. They are windows to our identities. Each curve, each line, each freckle tells a story. It's a story that artificial intelligence, in its relentless quest to understand our world, is learning to read. This is the essence of AI facial recognition, a technology that can identify or verify a person from a digital image or video. Facial recognition may seem like science fiction, but at its heart lies the marriage of two powerful forces: computer vision and deep learning. Computer vision gives machines the ability to see and interpret images much like our own eyes. Deep learning, on the other hand, allows machines to learn from vast amounts of data, mimicking the complex workings of the human brain. Together, these technologies have unleashed a new era of possibilities. Imagine a world where security cameras can instantly identify wanted criminals or lost children, or where our smartphones become our passports, unlocking a world of personalized experiences. This is the promise of facial recognition, a technology that is rapidly changing our world. But like any powerful tool, facial recognition comes with its own set of challenges and ethical considerations. As we delve deeper into this fascinating world, we must ask ourselves, what are the limits of this technology and how do we ensure its use responsibly? The answers, like the faces it seeks to understand, are complex and multifaceted. Imagine your face not as a collection of features but as a unique constellation of data points. This is how AI sees you. Facial recognition software doesn't see emotions or recognize beauty. Instead, it breaks down your face into a series of measurable features, a process known as facial feature extraction. Think of it like a digital fingerprint. AI algorithms pinpoint specific landmarks on your face, such as the distance between your eyes, the width of your nose, and the shape of your jawline. These measurements are then converted into numerical data, creating a unique facial signature or template. This process is incredibly detailed, capturing even the subtlest nuances of your features. It's like an artist sketching your portrait, but instead of charcoal on paper, it uses algorithms and data points. The result is a digital representation of your face, ready to be analyzed and compared. This facial signature is the key to AI's ability to recognize you. It's what sets you apart from the billions of other faces on this planet. It's the foundation upon which the entire edifice of facial recognition is built. Now that we understand how AI deconstructs faces, let's explore how it learns to recognize them. This is where the magic of deep learning comes into play. Deep learning algorithms, particularly those known as convolutional neural networks, or CNNs, are the engines that power facial recognition. Imagine a vast digital library filled with millions, even billions of faces. This is the training ground for AI facial recognition systems. CNNs are fed these massive datasets, learning to discern patterns and identify unique features that distinguish one face from another. It's like teaching a child to read by showing them countless letters, words, and sentences. Through repetition and exposure, the child's brain begins to recognize patterns and make connections. Similarly, CNNs, through repeated exposure to facial data, learn to identify the subtle nuances that make your face uniquely yours. This training process is computationally intensive, requiring powerful computers and vast amounts of data. But the results are astounding. AI systems can now achieve remarkable accuracy in recognizing faces, even in challenging conditions like poor lighting or partial obscuration. The journey of facial recognition, from pixels to predictions, is a testament to human ingenuity. Early attempts at facial recognition relied on geometric approaches, measuring distances and ratios between facial features. But these methods were limited, easily fooled by variations in lighting, pose, or expression. The advent of deep learning revolutionized the field, ushering in an era of unprecedented accuracy and sophistication. CNNs, with their ability to learn complex patterns from massive datasets, proved to be a game changer. Here's how it works. When a facial image is fed into the system, it's first pre-processed to enhance key features and normalize variations. The image is then passed through a series of convolutional layers, each analyzing different aspects of the face, from edges and textures to more complex shapes and patterns. Finally, the output of these layers is fed into a fully connected neural network, which makes a prediction about the identity of the face. This entire process, from pixel input to identity prediction, happens in a matter of milliseconds, a testament to the power of modern computing. While AI facial recognition has made remarkable strides, it's important to remember that it's not a flawless technology. Like any tool, it has its limitations and challenges. One of the biggest challenges is variability in facial appearance. Faces are not static objects. They change constantly based on lighting, angle, expression, and even age. A slight frown, a pair of sunglasses, or even a few years can throw off even the most advanced algorithms. Another challenge is demographic bias. Studies have shown that some facial recognition systems exhibit higher error rates for certain demographics, particularly those with darker skin tones or women. This bias, often stemming from imbalanced training datasets, raises serious ethical concerns about fairness and discrimination. Then there's the issue of spoofing or presentation attacks. Malicious actors can attempt to fool facial recognition systems using photographs, masks, or even deepfakes, synthetic videos designed to mimic real faces. This highlights the need for robust liveness detection techniques to ensure that the system is interacting with a real person and not a sophisticated forgery. When most people think of facial recognition, they think of security. And indeed, facial recognition has become an invaluable tool for law enforcement, border control, and surveillance. But its applications extend far beyond security, touching upon nearly every aspect of our lives. Imagine walking into a store and receiving personalized recommendations based on your purchase history, all thanks to facial recognition. Or imagine unlocking your phone or accessing your bank account with just a glance. No more fumbling with passwords or PINs. In healthcare, facial recognition is being used to diagnose genetic conditions, track patient medication adherence, and even assist individuals with visual impairments. Social media platforms leverage facial recognition for photo tagging, while marketing companies use it to analyze consumer emotions and tailor advertising campaigns. The potential applications of facial recognition are vast and ever evolving. From education and entertainment to transportation and retail, this technology is poised to transform industries and reshape our interactions with the world around us. Please like, share, and subscribe to the Beyond the Circuit to keep up with the exciting changes in AI, robotics, and more.
You